So another type of injection attack that a lot of systems can be vulnerable to is command injection. And command injection is sort of like the less popular of the injection attacks compared to SQL. And that's because it's a little harder to know what commands to send in through unsanitized input, even if an attacker finds unsanitized input. So it's a little more of like a blind luck kind of thing. With SQL, it's possible to really just assume that most systems today have some sort of SQL backstore somewhere in the stack, somewhere behind servers and firewalls and load balancers and gateways. Somewhere there's finally going to be some SQL query running to retrieve or update some data somewhere. And even in the world where we have NoSQL, we have a lot of different databases like Mongo and Cassandra that don't run SQL queries. It's a pretty high percentage bet that the system you're using is probably actually talking to a relational database, and somewhere in the layers of communication there's SQL. With commands, you really have to know what system you're targeting. And there's percentages here too. So again, it relies on unsanitized user input, and that means that it's suppose a form or some user contributed content that gets saved into a web application, or it's just some other way for a user to essentially store some text or something like text that will then get run by the web application or one of the systems that's part of the platform that the web application belongs to. And this all relies on some of this remaining uninspected. And we'll see how that works in our examples, but just remember that the whole trick here is the same between the two types of injections. It's really to sneak some unexpected stuff in as text, but have it behave not like text at all once it's in the system. And what this results in the case of command injection is the text that we are sneaking in and are using as part of the attack. It's coming in through unsanitized user input, and then it's getting executed as code on a system that is being attacked. And that means that somewhere along the lines, somebody implemented something on that system that lets user input be evaluated, or things from user input be evaluated on the system. And of course, like we said, part of the trick here is to know what kind of system it might be. So here again, one of the things that an attacker can rely on is that the majority of servers nowadays are Linux-based. They tend to be one of a few major flavors of Linux. And also, we know that a lot of enterprise systems run with Java installed. We know that a lot of enterprise systems run on Linux flavors like Red Hat, or if they're on a cloud provider like AWS, we know that they're probably running on Amazon Linux or one of the similar flavors. And of course, Ubuntu is very popular. You could have something rare where the system that you are actually attacking is something along the lines of a ZOS or something like that, but that's a lot rarer, especially for consumer-facing systems, ones that are available from the public internet. So a lot of web applications wouldn't necessarily be talking directly to those in a manner that allows a remote injection attack. And so knowing the system, playing the percentages, that's all part of using these injection attacks. But they're a pretty big deal because you could essentially, with the correct combination of things, send in something that starts to run malware, download and run malware on a server, which will then spread through the data center. So it can be a pretty major deal if something happens to get past the safeguards, if there are safeguards at all, and execute as a command on the server. And we'll see some examples of commands executing past any safeguards in our applications.